Let us find the zeros of g of x. So first, we'll look again at the degree. So the highest exponent of x is 4. So therefore, we say that the degree is 4. And therefore, we have to look for 4 zeros. Now, if you look at the sign changes, the first term is positive, negative, negative, positive, positive. So from the first to the second term, it's changing from positive to negative. So that's our first change. Negative to negative, no change. Negative to positive, that's another change. And positive to positive, no change. So therefore, there are 2 sign changes. Therefore, there should be 2 positive zeros. So that means out of the 4 zeros, 2 of them must be positive and 2 must be negative. Okay, so now let's look for the zeros. First, we need to make a list of the possible rational zeros. So here we're going to put the possible rational zeros. We are listing these zeros, the possible rational zeros, so that when we look for the zeros, we are only selecting from a small group of numbers. And so it'll be easier for us to find the zeros of the function. So this list will include positives and negatives. And this list is generated by taking the constant term, which is 18. We find the factors of 18, which is 1, 2, 3, 6, 9, and 18. And then the leading coefficient here is 3. So we list the factors of 3, which is 1 and 3. Now we are going to divide the factors of 18 by the factors of 3. So we start off by dividing these guys by 1. So 1 divided by 1 is also 1. 2 divided by 1 is 2. And so we'll just have these numbers listed here. So 1, 2, 3, 6, 9, 18. These are the integer possible zeros. Now we're done with 1. We will divide by 3. So 1 over 3, that's going to give us 1/3. 2 over 3, so that's 2/3. 3 over 3 is 1. We already have that. 6 over 3 is 2. We already have that. 9 over 3 is 3. And 18 over 3 is 6. So we have our complete list of possible rational zeros here. So now let's start looking for the zeros. So we list the coefficients of g of x. Now notice that the exponents are arranged from 4, 3, 2, 1, and then 0. If there is a missing exponent, for example, if we skip 2, let's say this isn't here, then that means that when we list the coefficients, we have to put a 0 in the place of x squared. Okay, but all of the exponents are represented here, so we will not have to replace anything by 0. So we'll just take here 3, -3, -21, 3, and 18. Okay, so we have two positives and two negatives. So let's start off with some positive numbers. So let's start with 1. Is 1 a 0 of g of x? So let's find out. First thing we do is bring down the 3. We multiply by 1. We put the answer here. Then we add and we get 0. We have to continue all the way here. When we get a 0 here, then we find a 0. We found a 0 here in the second term. This does not mean that 1 is already a 0. We have to continue. So 0 times 1 is 0. And negative 21 plus 0 is negative 21. Negative 21 times 1 is negative 21. We add and we get negative 18. We multiply by 1 and we get negative 18 right here. And we found a 0. So 1 is a 0 of g of x. Okay, so let's find the next one. Now, let's try if negative 1 is a 0. So normally when we try 1 and it works, then we have to try negative 1. Then we try 2 and try see if it works. If that doesn't work, we try negative 2, so on and so forth. It's good to start with small numbers. Okay, so let's check if negative 1 is a 0. So bring down the 3. Multiply by negative 1, we get negative 3. We subtract, or we add rather, which is negative 3. Negative 3 times negative 1 is positive 3. Negative 21 plus 3 is negative 18. Negative 18 plus 1 times negative 1 is positive 18, and then we get a 0. So we found another 0. Sometimes we are lucky enough to find zeros quickly, like this. Now let's try 2. So we bring down 3. 3 times 2 is 6. Negative 3 plus 6 is positive 3. 3 times 2 is 6. And we get here negative 12. That means 2 is not a 0. Okay, so 2 is not a 0. We will erase that. Okay. Now this time, let's try if negative 2 is a 0. So 2 doesn't work, we try negative 2. Which is okay to try negative 2 because we're looking for a second negative 0. So we bring down 3. 3 times negative 2 is negative 6. Negative 3 minus 6 is negative 9. Negative 9 times 2 is 18. There we go. We have a 0 right here. So we found our third 0. Now notice that this is only 3, negative 9, 0. There's only 3 numbers here, and the last one is a 0. So this is 0, this is the constant term, and this is the x term. So we can write this as 3x minus 9 equals 0. And so we can now solve for x. So we're going to add 9 to both sides. Therefore, 3x is equal to 9. We divide both by 3. And so we'll have, okay, let me just bring it over here. X equals 3. This is our last 0. So we found all the 4 zeros that we are looking for. 1, 2, 3, 4. 2 of them are negatives and 2 of them are positives. Okay, so now that we have found the zeros, so let's list the zeros here. Maybe I'll put it here. So zeros of the function are 1, -1, -2, and 3. Okay, now let's find the y-intercept. So y-intercept is g of 0. Okay, so g of 0 is equal to 3 times 0 minus 3 to the 4th minus 3 times 0 to the 3rd minus 21 times 0 squared plus 3 times 0 plus 18. This is going to be 3 times 0 times 0 times 0 is 0 minus 3 times 0 times 0 times 0 is also 0 minus 21 times 0 times 0 is 0 plus, well, 3 times 0 is 0 plus 18. Now, any number multiplied by 0 is equal to 0. So 0, 0, 0, 0. If we add or subtract them, we get 0. So therefore, we'll have here 18. So we'll have g of 0 is equal to 18. This is the y-intercept. Now, in order to sketch the graph, we have to put these numbers, our zeros, in a number line. And we will do the same thing that we did with graphing by hand, but in factored form. But I think this is going to be a little more complicated. So we'll have -2 here, -1, and 1. Okay, let's make this longer. And then 3 here. And we want to find the signs of g of x in each of these sections. So actually, we just want in this section. So we're gonna try here -3. Okay, so what is the sign of g of x when x is -3? How do we find that? Well, we just need to do the same thing that we do here, because this is how we can find the value of the function when x is this number. So remember, g of 1 gives us a 0. G of negative 1 will give us a 0. Okay, so what is g of negative 3? So let's find here g of negative 3. G of negative 3 is, again, 3, negative 3, negative 21, 3, and 18. We want g of negative 3. So we bring down 3, negative 9, negative 12, 36. This is 15. This is negative 45. This is negative 43. No, 42. And negative times negative is some positive number. And add that to positive 18, we're going to have a positive number here. Therefore, g of negative 3 is positive, and therefore it's going to be above the x-axis. So at negative 2, g of x will be approaching negative 2 from above. And then because the zeros occur only one time, the graph will cross the x-axis at those x-intercepts. And it will cross the x-axis quickly. So it will cross it here, it will come back, and then cross here, and then come back. This is how the graph of g of x will look like. But if we want to sketch, let's do it here. Okay, so let's count by ones. But so for the x, we're counting by ones, but for the y's, let's count by, say, 6. So 6, 12, 18. So this is negative 6, negative 12, negative 18. Okay, so now let's put the x-intercepts. For the x-intercepts, we got 1. We have negative 1, negative 2, and 3. So these are the x-intercepts. Then we are going to copy the shape. So that means, let me use green, that the graph starts here above the x-axis, touch the x-axis at negative 2, come down, go back up, touch this. Now we need to put the y-intercept because we're approaching the y-axis. So the y-intercept is 18. This is the y-intercept. Let's mark that with red. Y-intercept, and then The graph will keep going up and then come down, touch 1, and then go back up. There's the graph of g of x.